While recent researches on computational 3D scene synthesis have achieved impressive results, automatically synthesized scenes do not guarantee satisfaction of end users. If an end user has a specific preference of placing objects, then few guaranteed layouts satisfy this user. For example, one could ask the desk somehow being put against the window, the wardrobe somehow being put near the door, and the double bed somehow being put against the wall, facing the north. On the other hand, manual scenes modeling can always ensure high quality, but requires a cumbersome trial and error process. In this paper, we bridge the above gap by presenting a data-driven 3D scene synthesis framework that can intelligently infer objects to the scene by incorporating and simulating user preferences with minimum input. While the cursor is moved and clicked in the scene by end users or computer simulations, our framework automatically selects and transforms suitable objects into scenes in real time. Given a cursor movement at any moment, our framework automatically selects, translates, and rotates an object plausibly into the scene. Clicking would end an interaction and refresh priors, which introduces more potential objects and constraints. When the cursor is moving, we achieve real-time emergence of objects with proper transformations. In this paper, to achieve both real-time and plausibility, we divide objects into 3 classes. Demand objects which are selected and transformed independently of other objects. Subordinate objects which are inferred depending on the demand objects they are belonging to. And wall objects which are not standing on the ground or other objects, but attached to the wall. Each class learns different structures of priors and follows its own way of inference, which is based on intersected positions. We next show the workflow of a single movement. After obtaining a movement of the cursor, we first compute intersected positions based on recasting from the perspective camera to directions of the cursor. If the intersection falls on walls and matches one or more wall priors, a wall instance is selected and transformed based on the best matched prior. Otherwise, it proceeds to the next interaction with regard to a new movement. If the intersection does not fall on walls, it first tries matching subpriors. If matched, a subordinate object is inserted similarly based on priors. If no subprior is matched and the intersection is on the ground, we finally try inserting domain objects. The detail of inferring the 3 classes of objects are illustrated in the paper. Here we show how users use our framework to interactively synthesize rooms. Here are the resulting scenes. User studies showed that our method significantly reduced the time consumption of arranging a scenes while keeping the plausibility, aesthetic, and system usability. We have demonstrated the MageAdd, a new interactive modeling tool that enables the real-time modeling of realistic indoor scenes. This is the end of our video. Thank you for watching.